Good morning, everybody. In this video, I am going to talk about Newton's law of cooling. A mathematically similar physical principle is Newton's law of cooling if you introduce a hot object into cold surroundings, or equivalently, a cold, a cold object into warm surroundings. The rate at which the object cools or warms isn't proportional to its temperature, but rather to the difference in temperature between the object and its surroundings. Symbolically, symbolically, if we let y of t be the temperature of the object at time t and let t at a Ta be the temperature of surrounding, the ambient temperature, which we assume to be constant. We have the difference equation. Y prime of t is equal to k times the difference between yt and temperature or temperature ambient or ambient temperature, sorry. Here, how to find the general solution for this equation. This is differential equation. Let's to show you how to find the general solution for this equation. Here y prime is equal k times y of t minus ambient temperature, yes, Ta, ambient temperature is good. Here dy over dt is equal k times y of t minus t ambient t temperature, yes, Ta. Good. This is denominator 1. We can multiplying in this direction and multiplying in this direction is okay. Dy times 1 is equal dy times k times y of t minus Ta times dt. Right? Here we can divide it both sides, the difference y of t minus temperature ambient is good. Here y of t minus Ta, we can cancel this and this to get it here. I think dy over y of t minus t ambient, or es, is equal k dt. The next step, integrate both sides, integral dy over y of t minus t at, or Ta, is equal integral k dt. This is equal ln, yes, absolute value, y of t minus Ta. This is equal k times t plus c. So I continue here. We can write y of t minus t at 8 is equal what? E power kt plus c. Okay. Now we can write y of t minus t a is equal e k times t times e power c. This is, I can suppose this a. Yes, we can write here y of t minus ta is equal a times e power kt. We can move to the another side, change the signal. Yes, y of t is equal a times k t plus t ambient. Okay, this is Newton laws or a Newton law of cooling. Okay, we can take application or example about this law, Newton's law of cooling. This example. Okay, a cup of fast food coffee is 180 Fahrenheit when freshly poured. After 2 minutes in a room at 70 Fahrenheit, Fahrenheit, the coffee has cooled to 165 Fahrenheit. Find the temperature at any time t and find the time at which the coffee has cooled to 120 Fahrenheit. This is the question. Let's to explain this question step by step and take the given information from the question to start or apply or using Newton's law of cooling. Okay, we know here Newton's law of cooling y of t is equal a times e power k t plus temperature surrounding or ambient is okay. Good. Here, this is a initial temperature for this object. This is for cup of fast food coffee. Okay. After 2 minutes in a room, which the temperature of a room, this is the surrounding. Yes, 70 This is 70 This is here a 70 Fahrenheit. Okay, sorry. A is equal 180 Fahrenheit. Okay, T ambient is equal 70 Fahrenheit is okay. We can use this formula, substitute in the general formula or Newton laws of cooling. Okay. But here the coffee has cooled to 165. Okay, we can write here 165 is equal a 180 times e power k t here 2 minutes plus 70. Okay, we can move 70 to the another side, change the signal. 165 minus 70 is equal 180 is okay Fahrenheit. Times e power 2k. Here I think 95 is equal 180 e power 2k. We can divide it both sides here. 180 here 180 to get it here. 59 over 180 is equal e to power 2k. We can take the logarithm. I'll go logarithm for both sides. Ln here 95 over 1800 is equal to k. Yes, divided, I think here both sides 2, we can get it here half ln 95 over 80. This is the value of k. Is okay. This is the question. The question: find the temperature and at any time. This is the first question. Okay, we can substitute for general formula. Y of t at any time is equal a 180 times e power k. What is k? Half ln here 95 over 180 is okay times t, okay, plus 70. This is the general formula to find the temperature at any time. The second question: find the time at which the coffee has cooled to 120 Fahrenheit. Okay, we can substitute here. 120 Fahrenheit is equal 180 e power half ln 95 over 180 times t plus 70. We can this move to the another side, change the signal. 100 minus 70 is equal 180 times e power half ln 95 over 180 t is okay here. 50 equal 180 e times half ln 95 over 180 times t. We can divide both sides here over 180 to get here 5 over 18 is equal e power half ln 95 over 180 t. We can continue on the other side. Okay, 5 over 18 is equal e power half ln 95 over 118 t. We can take here logarithm for both sides. Ln 5 over 18 is equal half ln 95 over 180 t. Yes. Here can continue divided both sides, I think. This is half ln 95 180, both sides here, half ln 95 over 180. We can get it here t. This is cancelled. This is t is equal ln 5 over 18 over half ln 95 over 80. This is, you can find this is equal minutes. You can find this by using calculator. Thank you for watching this video. We'll see you inshallah in the next video. Assalamu alaikum.